Hey guys, welcome to Geometry. We've got a great year of learning ahead of us, but before we jump in, let's learn some terminology. As the great Galileo once said, you cannot begin to understand the universe that surrounds you until you understand the language in which it is written. That language is mathematics, and especially geometry. So today we're going to start off by learning a bunch of terms that are going to support us the rest of the year. The first three terms that we're going to learn are considered undefined terms in geometry. Now, those terms are point, line, and plane, and you see them here. A point is simply a location in space. Now, that doesn't mean outer space, but you can kind of think about it like the stars in outer space. They are simply little locations that are zero-dimensional. That means they have no width, no length, and no height. So here's some examples of points A, B, C, and Z. Now, they're denoted with just capital letters. So this is noted as point A. Likewise, this is point Z, B, and C. So you're always going to denote that with a capital letter. Let's make an additional point here. We'll call this point D. All right, the next undefined term is line. Now, a line is a collection of points in a line that extend in opposite directions forever. In other words, they form a line. And this is considered one-dimensional. It has a length. You can measure a line's length. So here's an example. This is line AC. Now typically you'll see lines drawn with arrows on either end indicating that they extend in both directions forever. Now there's a couple of ways to denote a line. You can use the two capital letters that represent the points that are on that line. So here's line AC, and notice that it gets a line with two arrows in opposite directions over the top of it. Or you can also denote this as line M. Now that's a lowercase script letter, kind of like a cursive letter. So those are two different ways. Pick 2 points, represent them with capital letters, put the line with opposite arrows over the top. Or you can use a lowercase script. Now the third term that we're going to talk about that's undefined is called the plane. Now a plane is a collection of lines creating a two-dimensional surface. It's two-dimensional because it has both length and width. So here's an example of a plane. Now we would call this plane, and we have to use 3 letters, such as E, D, and G. All 3 of those letters have to, all 3 of those points have to exist in the plane. Or you could also denote this as plane, capital K, and that's a scripted K. All right, so 2 different ways to denote a plane, 2 different ways to denote a line, and 1 way to denote a point. All right, moving on to some more definitions that are going to be critical to our study of geometry. The next is a line segment. So if a line extends in opposite directions forever, a segment is simply a part of that line. It has a definitive beginning and ending. Now, those definitive beginning and endings are called endpoints, and those are just simply points. So over here on the right, we have an example of a line segment. This is segment BZ. The way I would denote that is segment, capital B, capital Z, and it gets just a bar over the top. Notice that there are no arrows indicating that it's not going on forever in either direction. Now, it doesn't matter which order I list these letters in. I could also denote the same segment as segment ZB. All right, endpoints, as we mentioned, are simply the beginning and the ending points of that segment. Now, array is different. Array is a collection of points starting at 1 point and going on in one direction forever. So here's array HI, and again, you would typically see that ray with an arrow at the end of it indicating that it goes on in that direction forever. How we denote that is 2 letters, 2 capital letters, so here's capital HI, and array, that means it's going to get an arrow with a arrow pointing in one direction. Now, the order of which we list these 2 capital letters does matter. Because it begins at H, it has to start with H. The arrow goes in the direction of I, indicating that it's going to pass through I and keep going on in that direction. To write this ray as IH with the arrow going this way is incorrect. So be careful of that. All right, now opposite rays are 2 rays that extend in opposite directions from the same starting point. So I could continue a ray HL and go off in this direction if I put L right here. And now I have ray HI, and now I have ray HL. And these are considered opposite rays because they form a line. They extend off in opposite directions forever. Okay, let's talk about collinear. Collinear means together on the same line. So 3 or more points that lie on the same line are considered collinear. Here are points J, A, C, K, Jack. Jack is all on the same line. So these points are considered to be collinear. And then finally, midpoint. Midpoint is the point on a line segment that divides the segment up into 2 equal halves. So take, for example, this line segment A, B. If I were to divide it in 2 equal halves, we're going to be calling that word congruent, 2 congruent halves. Then here's point C, and C is considered my midpoint. All right, so let's get a little practice using our notation to draw an example of the following geometric terms. In letter A, I see I have 2 capital letters with an arrow going off in one direction. This is a ray. So I know my starting point has to be A, and it's going to pass through B. Here is an example of ray AB. The next one, I have arrows going off in both directions. So I know that this must be a line. Here's 2 points, F and R. And I'm going to create a line that passes through those 2 points. The next one has JK with just a bar. That must mean that this is a segment going between 2 endpoints, J and K. Next, I see I have line with a lower script S, so I know that this must be a line extending off in both directions. And I'm going to label a little s at the end of that line. All right, the next is plane T, so I'm going to kind of create this parallelogram shape, indicating that this is a 2-dimensional surface, and I'm going to put my little script T down here in the lower left-hand corner. All right, the next is point X. That's an easy one, just a capital X next to a point. And now I want opposite rays TW and TP. So again, my starting point must be T. If I go 1 to the right here, we'll call this TW, and 1 to the left, here's TP. And finally, I want 3 collinear points, A, H, and M. So that's easy enough. I'm going to create my line, and I'll create those 3 points. It doesn't matter which order they go in. There are 3 collinear points. All right, in our final example for today, we're going to take a look at this drawing, and we are going to use our proper notation to note one of each of the following. So if I take a look at this, I see that I have this plane T that's kind of coming out of the board at me or out of the screen, and then plane N going up and down. I have line AC on plane N. It looks like BC is kind of passing through both of those planes, and it's kind of the intersection of those 2 planes. So let's denote a line segment. Now, a line segment just connects 2 points, so we could use line segment AC. I do have to use my proper notation. I know a line segment gets a bar over the top. A ray starts at 1 point and goes off in one direction forever, so I'm going to use ray CB. Now you could have also done CA or CD. How about a plane? Well, I have a couple of examples of planes here in this image. I'm going to choose plane N. All right, the intersection of the 2 planes, it looks like I have this intersection of the blue plane and the orange plane that occurs right here at this segment BD. So I'm going to call that line BD. The next one says the intersection of the 2 lines. Well, I see the 2 lines here, AC and BD, look like they intersect at point C. So I'm going to just denote that as point C. Finally, I'm going to pick a point. Doesn't matter which point I pick. I'm going to pick point E. And then I want 3 collinear points. So let's choose B, C, and D.